these are your 4-3B notes, still using point slope form, but now they're going to get a little trickier. They're going to give us clues in regards to the line, and we have to come up with the equation. So like I mentioned yesterday, point slope form is a transitional form. We use this form mostly to give us slope-intercept form, or maybe they'll ask us to put it into standard form. Very rarely do they just ask us to keep it in this form. Yesterday I did, just to kind of get you used to it, but this one's usually going somewhere else. But this is always where we start. If you guys can get anything from this chapter besides graphing a line, is you're going to see this being used over and over and over again. So they're going to give us clues. The clues change, but in the end, we're doing the same thing over and over again. So to do this, we are simply going to find the value of the slope and substitute it for m. Now, sometimes we can skip that step because they give us m, so we don't have to find it. They just actually give it to us. But if not, we may have to, in this case, use the slope formula. So go ahead and put that in your notes just so you have it from chapter 3. If they don't give us a slope, we'll have to find it. Maybe that means counting. Maybe that means using two ordered pairs and calculating. Find the coordinates of one point on the line and substitute for x and y. So sometimes they give us more than 1 point. You just got to use one ordered pair. Once you have an ordered pair and slope, these two things, you can use point slope form. You need the point and you need the slope, and then we can substitute them in. You're going to distribute and use inverse operations to create the different forms needed. We did that yesterday. We distributed through and put it into standard form. We distributed and we put it into slope-intercept form. So it just depends on what they ask for is what form we end up giving. But we always start with point slope. So let's go ahead and try this. It says write the equation for the lines described below in slope-intercept form. So our end result needs to be this, but that's not where we start. Okay, we're going to start with point slope form. So they gave us a point. Here's my point. Here's the x and the y. And they gave us the slope, 1/2. So I'm just going to write this down sort of as a formula. Y minus y equals m times x minus x. We'll probably put this on the top of our paper today, just so we always have it. This is where we're starting. So I'm going to put the point in there. The -3 turns into y plus 3 equals, my slope is 1/2. And then my x value is my, x minus 2 because it's a positive 2. Can't leave it like this. They want us now to put it into slope-intercept form. So they gave us clues about a line. This line has a slope of 1/2 and passes through 2, -3, and they want us to create the slope-intercept form. So I'm going to go ahead and distribute that 1/2 through. I get 1/2 x. When I multiply the 1/2 times the -2, that leaves me with a -1. Sometimes you'll get a fraction, sometimes you'll get a whole number. Almost done. In order to get it into y equals mx plus b form, I need to move this 3 away from the y and over with this -1. So the -1 and -3 can go together. The 2 3's cancel. Y equals 1/2 x minus 4. And so what we just did is we used this form to get me to this form. And now I can see if I wanted to graph, I could use either one to graph. But I know now that this graph has a slope of 1/2 still. And this graph also, not only does it go through this order pair, 2, -3, it also hits the y-axis at -4. We have so much information about this graph. Let's try it again. 2 is a little trickier with its clues. It's giving us a point, but when it gave us this point, it didn't actually say it's a point. But that's actually an ordered pair. So we have our slope, -3. X-intercept of 2 means where it crosses the x-axis. So if it's an x-intercept of 2, they're sneakily giving us this ordered pair, 2, 0. So there's my x and y. So again, I'm going to use y minus y. So y minus 0 equals m, which is -3, times x minus 2, putting it in point slope form first. And then we distribute to put it into slope-intercept form. Y minus 0, or I could just call that y now, right? Y minus 0 is just y. And so we don't have to move that 0 over. We just got to distribute. -3x plus 6. So this one required a couple different steps. I had to distribute, then I had to subtract the 3 here. This one, minus 0 just kind of goes away. And so less work, right? There's your slope-intercept form of the equation. So not only does it go through an x-intercept of 2, this is telling me that if I have a negative 3 slope, I'll also go through the y-axis at 6. And if I count all the way down there, 3, 1, 2, 3 over 1, I'm here. If I do it again, I'm at that 2. I know we didn't have to graph it, but I'm just kind of showing you. They gave us this point. We found that point. All right, let's go ahead and try a few more. Looking for slope-intercept again. Sometimes they say standard, but the majority of the time, they want us to put our answers in this form. That's why I keep showing you this form. So that's our end result. That's our answer, but we're going to use point slope form to get there. And this, guys, is going to carry on throughout the rest of these sections that we do in this chapter. So the clues this time, they didn't give us slope. They gave us 2 ordered pairs. So he's got to work a little harder, a little longer here for the slope, and then we pick a point. So I'm going to use a slope formula. Here's my x and y. Here's another x and y. I need to figure out the slope. So given 2 points, I can subtract the x's and subtract the y's using my slope formula. Equals, I'm going to put the negative 8 second so that when I subtract, remember the slope formula is y minus y and x minus x. So when you plug in negatives, they turn into positives. So I'm going to put negative 4, the second negative turns into a positive. Minus a negative becomes plus positive. So negative 4 plus 8. Since I started with negative 4 here, I have to start with negative 3 on the bottom. Negative 3 minus a negative 2 becomes plus 2. And so then just simplifying that, negative 4 plus 8 is positive 4. Negative 3 plus 2 is a negative 1. So this is a negative 4 slope once I simplify all of it. From there, now what we're going to do is everything we did before. Okay, this is the interesting part. It doesn't matter what order pair you use. Okay, I can use negative 3, negative 4. You could use negative 2, negative 8, and we'll get the same answer at the end. That's kind of magical. Let's go ahead and use the smaller numbers. Let's just be consistent here. But in class, like I said, you could use one and the person next to you could use the other. You could compare your answers and see if you got the same result. You should, if both of you did it correctly. So I'm going to use the negative 3, negative 4. Y minus a negative 4 becomes plus 4. Plugging in the y value equals slope negative 4. And then x minus a negative 3 becomes plus 3. So just go back and I redo everything we already did. I'm going to distribute the negative 4 through. So y plus 4 equals negative 4x minus 12. I got to get rid of this plus 4 over here by the y. It goes with the negative 12. They are like terms. So the 4's cancel. Y equals negative 4x minus 16. Okay. And then I'm going to just quickly go through that other one. You can write it down. You don't have to write it down, but I just want to show you the side-by-side of how it actually gives you the same result. So I'm going to go a little faster. If I used this one instead, and I'm not going to do this for all of them, but I think it's an important valid point. Y plus 8 equals negative 4, and then x plus 2. I should get the same results. Okay, my numbers look completely different. If you look at the dark blue and my red, completely different numbers. I'm going to write down y plus 8, distribute the negative 4, just like before. Negative 4x minus 8, completely different numbers than what I had here, right? And then instead of subtracting 4, I have to subtract 8. But when I subtract 8 from the negative 8 that's already there, I mathematically get negative 16. Whoa, crazy, huh? So that's another way you can check your answers. Another way you can check your answers is plug in the other ordered pair into the equation you got. Plug in negative 2 here and negative 8 here, and it should give you a true result. Is negative 8 equal to negative 4 times negative 2 minus 16? And it is. Negative 4 times negative 2 is positive 8, and if you subtract 16, you get negative 8. Negative 8 always equals negative 8. So that's another way to check your answer. Use one ordered pair to plug in and create the equation. Use the other ordered pair to check your equation. And that check, like we did back in chapter 2, just put that all in your calculator and see if it equals -8. So just some options there. So number 4, let's go ahead and do this one more time here. So I got to find the slope. Y minus y, I'm going to do the 4 on top first. So 4 minus a -2, that just puts my -2 second, turning it into a positive. If I pick 4 on top first, I have to put 3 on the bottom first. 4 plus 2 is 6. 3 minus 6 is -3. 6 divided by -3 is a -2 slope, or -2/1. Okay, and then pick one of the ordered pairs. I'm just going to use 3 and 4. So y minus 4 equals -2x minus 3. Distribute. It's the repetition, guys. The more we do this, the more it becomes second nature. Y minus 4 equals -2x plus 6. Add 4 to both sides. The 4 and the 6 are like terms, so I'm going to put it underneath the 6. The 4's on the left-hand side cancel. Y equals -2x plus 10. And there's your equation. Okay, word problems. Same concept. During 1 year, Matt's cost for gasoline was $3.20 on the 1st of June, and then $3.42 on the 1st of July. Write a linear equation to predict his cost of gasoline the 1st of any month during the year, using 1 to represent January. So each month has its own designated number. So 1 would be January, 2 would be February. So the 1st of June would be 6. So I'm going to use 6, the 6th month, $3.20. And then July would be 7th month, $3.42. Now, this is assuming that if January was the 1st, if I went to the next January, it would be the 13th month. So you'd have to do a little bit of calculating your months, because you can't just revolve back around. It's from that beginning January or this beginning June. So I have 2 ordered pairs. Okay, so we're going to use a slope formula. It's sort of like a rate of change, right? 342 minus 320, my y minus my y, and then my x minus my x. So the 7 minus 6 gives me 1 on the bottom, and then 342 take away 320. I don't trust my mental math. I think it's 20 cents, 22 cents. Yep, 22 cents. So this is my slope. My slope is 22 cents. It's rising 22 cents each month. And now I just need to put it into my formula. So when I do the formula here, I'm going to do y minus y. I'm just going to use the first one. Y minus $3.20 is equal to 0.22, 22 cents, x minus 6. See, the prices, we have to go back to January. We were given information in June. We got to go back to January. That's what this will do. It'll take us back to the beginning of how much the gas was. If it's raising 22 cents each month, it's going to take us back 6 months and subtract those 22 cents each month. You can do that using guess and check, but algebra is so much quicker and easier to just have the equation do it for you. That's the whole idea of it. It's more efficient and more accurate. So the 22 cents times the 6 is $1.32. That's saying we had all those increases were $1.32 collectively. Add 320 to that. And so really what we're doing is we're subtracting that 132 from the 320. And we have $1.88. Y equals, there is 22 cents gas increase since January, and it started off with as $1.88. So there's your equation. So now it tells us on average, Matt uses 25 gallons of gas per month. He budgeted $100 for the month of October. Use the equation above to determine if Matt will have to add more money to his budget for October. Well, if he uses 25 gallons per month, and he's starting with, so for the month of October, let's figure out how much it's going to cost for that month. So Y equals, it's 25 gallons. And so Y equals 22 cents, 25 plus $1.88. So according to this, oh, I lied, not 25 here. The month of October is 10. That's what we should be plugging in there. This is per month. So each month is the X. I know it's kind of hard to understand that. Starting with $1.88, but each month we're adding 22 cents. Starting in January, that'd be the 10th month. So let's see if that works out. And if we do the formula, 22 cents times 10 plus $1.88. The $4.08 is telling us how much it's going to be in October. So if he drives 25, he uses 25 gallons. If you multiply that by 25, he's going to be shy. He needs $102 in October. So little extrapolation there. I know in the bottom there, it talks about using the linear extrapolation. It's where you model beyond what you have. We can talk a little bit more about that in class, about saving up money and that sort of thing, budgeting, and using linear data to do that. All right, we got a freebie today on your lesson summary, and then I thought your practice problem should be something here, maybe, maybe not. Where are you? Oh, there it is. Write the slope-intercept form of the equation that has a slope of -3 and goes through that ordered pair, 2, -1. Go back to one of your first two examples and try to mimic what we did there. Good luck.